let's record. And right, so in here we went up to loader, if you can remember. After this is the main memory, how the that works, right? You have a stack, heap, and when it comes to execution, that's happening in the RAM, right? So that's what happens. Nothing much here, right? So do you have any idea about that, that note we started on that day? You can go ahead and just add that part, right? So in RAM we have the heap and code this thing. Where is that? Right. Yeah, so when it comes to software, I just wanted to show you another thing. This is that, right? So we are in this system software part, right? So this is from O-level knowledge I wanted to show, and these are called application software, right? So in the system software, all the things like how the cleanup works, this cleanup, all of them are in this place, right? And when it comes to application software, these are the softwares we go and install, right? We have MS Word, presentations, we have, PowerPoint, spreadsheets, we have Excel, like that. So we are going to only cover this part in the OS part with the system software, and some of utility software will be covered, right? So that's how software is being categorized, right? So I think I didn't share that part to you, right? This is the place that we went for, right? So we talked about these, and I said about these are softwares related to this way, right? So last part after this, just add the stack here, right? That's the part we need to add. Right? After this, it will be stored in the RAM. Um, and whatever right now I'm doing here is in my RAM, right? That's how it will be there. Right? In RAM, you have these things, right? You have the heap, you have all of them, right? So can take this down and get the heap. What do you mean by heap? Do you have any idea about it? Um, we have the stack, right? So when it comes to heap, that is the uh, days that you will be storing in the beginning when you get into RAM, right? So it's like first come, first serve basis. So when it comes to RAM, when they are processing, it will be taken from heap. Um, Whatever the things we do, the processes will be taken, right? So that's how we have these um, part. So once we are getting these objects to the loader, right? I hope you remember this order, right? And you can go ahead and add that heap stack thing, because that's important, right? So when it comes to this one, right? So execution part, it is a separate thing from loader, right? We have to add that line, right? Just add a, right? Because you will be asked questions on what is linker, loader, a lot of questions on that when it comes to operating system MCQs, right? In the first part of your A-levels paper, you will have questions from these, right? So you should have a clear idea what is these compilers, linkers, loaders, heap, stack, what are the execution happening here, right? So until now, it is not executed, right? We are just preparing to execute this executable file, right? This exe file, right? So the execution will be happening inside the RAM, right? So that's the most important thing that you should know, right? Nothing is getting executed until loader. Once you get it into the loader, an execution file with .exe, then it will be executed in the end of our um, RAM, right? Executable file will be uh, added to here, right? So here it is shape.exe, and this file will be loaded to the RAM. Right? So all executable files are getting loaded to RAM, right? Nothing else, right? When it comes to here, that's how execution happens. Right? So we'll add a small note on what is heap and what is stack as well. I hope you wrote it down and slowly write it so that we can discuss about other parts later. Tell me once you are done with this part, we'll write about stack and All right. So we'll go for that part because I can't write here. I don't have enough space. So I thought to check with you and, go a bit down from here. And we will discuss on the difference between what is stack and what is heap, right? Heap and stack, right? So stack is where we have um we can have a small table kind of a thing because this is another important part when it comes to here, right? You have to know what's the difference between heap and stack, right? So we are going to get the difference between these two, right? So stack is a linear structure and heap is a hierarchical structure. I'll tell you what's the difference between hierarchical and um, linear, right? So hierarchical means there is a the way that the data will be stored, the executable files will be stored in a hierarchy, right? So hierarchy means like this way. I'll show. Um, like in here, there is a one file, the top file that is say first one is like this. All the executable files under this shape will be in a hierarchy like this. It will be, um, having subparts of that thing, right? As a hierarchy is something like this, right? And inside here we have circle and those kind of things. So when it comes to shape thing, circle is a sub file that is being used. So it will be stored as well, right? So yeah, executing shape, but inside it is having the links of the shapes, circle, rectangle and square, right? Sorry. We have to make it rectangle and square, right? So I'm writing rectangle, square. And when it comes to linear, linear means it's going one after the other, right? So we have shape in here, and then we have it next, it will be having like this way, right? Heap, right? So rectangle will be having here, and this is how we have it in stack, and this is how we have data stored in heap, like so one after the other data will be executed in uh, stack structure, and heap it will be having a hierarchy after what we have like here. So it depends on how you want it to be. Right? So stack and when it comes to stack, right? So you will not have it like this way, right? So say a book stack, right? You will have it one after the other in a linear way, right? So you have to draw it not this way after this one. We'll have it as a book stack when you stack it one after the other. It is in a linear form. So you have it inside it like this way, right? So first it will be getting into the shape part, then the rectangle will come, then the square. So not like in the heap. Okay? So that's the difference between hierarchical data structures and linear, right? So one is this way, and the other difference is when it comes to stack, it is not getting fragmented, right? What is fragmentation? Fragments means to make it easy to process, we try to get the files into two or three different pieces, right? So based on the memory in when it comes to a heap, it will be stacking it as small fragments in here, right? So in heap, this one, right? So its shape, when it comes to RAM, one segment or one fragment of the shape file will be stored based on the RAM space, right? So one part of shape is here, and the next part, if you have space in this place in RAM, you will have in here, right? So it is fragmented, but stuck. It is not in a fragmented way. Shapes or will be not shares, divided into separate small pieces and have it, right? So fragments means getting it into two or three sections based on the way you want it, right? So you can get more space allocated in a stack because you're fragmenting it, right? This is not fragmenting, right? So blocks of memory will be, can be fragmented. And it's not always, if you don't have much space in RAM, you will get it divided into small blocks so that we can remove the first allocated block when we execute it from RAM. Right? So say the part one in here, if it's done, it will be removed from this place, and you can get that memory free. So stack is more, so actually heap is more easy to manage than stack, right? Um, Right. So when it comes to this one, because it's not in fragmented spaces, you can't resize it, right? But heap can be resized and make it small when it's say one part is executed this first part as in heap, right? So try to draw this part as well, right? So once you execute this file, right, it will be removed from your RAM, right? So when you remove that, the data fragments will be getting smaller, right? And the executable file is getting resized. One part is here and the other part may be in here. So these two will be getting together and there will be a link, right, to understand it, right? And you can get these two linked and the resize section will be happening. That means it is getting stored, and when you remove the fragments which are processed in RAM or executed in RAM, it will be resized. That second and third only will be there, right? But because it's not in stack, it is right. So that's why, right. So I think what right? Yeah. So this is actually what I drawn here. This is not right. If you can see, this is how the fragmentation happens in heap, right? Don't write it as stack, right? I forgot to write it. This is how data is stored in RAM, right? So in heap part, right? It will be in free like segments, right? As in here, but in this one, in shape on stack, it is in contiguous blocks, right? It has to be continued without having a random order, right? So in stack, it will be going the full file, which is not fragmented and not resized, is going one file, and then it will be continuing the order like this way, right? Without getting executed first part and removing it, it will be continuing to do it like square will be first executed, the next rectangle like that goes on. So continuity is there, right? Randomly, when it comes to heap, you can execute things, right? You can execute three first and execute two later, right? Like that. In heap, it is different, and in stack, this is how this work, right? So this is in heap of the RAM. If you have any questions, please ask Rima so that we can, you know, get an idea about these things. When it comes to questions, what is the difference between stack and heap? There will be questions based on that. So, in all A level, right, that's very important. Um, right. So in stack, we will be storing the data of any variable temporary, right? And when it comes to right, this is in heap, right? So what's the difference? We'll write a small thing about the difference. Actually already wrote it. And so this is the difference, and that's important. Um, right. So heap, it stores data in a dynamic memory allocation. Dynamic means somewhere around, you can just take it like in dynamic way. Randomly it will be stored in this place, like that. So it is having a dynamic memory allocation. But when it comes to stack, it is not dynamic, it is static. So that's another difference between these two, right? So it is storing data temporary. Temporary. It removes data when task of execution is completed. Computing task will be better word, right? The processing task, once it's executed, only it will be removed, right? But here you will be removing it. Once the fragment is processed, it will be removing, right? So that's how this works. All right. So I forgot to record first. Right. So in this thing, Pamela, I'm just telling so that here the fragments are here. This part is I think up to here we recorded from the first part, right? So this heap thing, it is more into dynamic memory location, and this is a static thing because it's temporary storing data. And heap, you will be removing things fragmented ones. So this is more faster, right? When it comes to doing tasks, heap does things very fast, and stack does things slowly, because you are removing unwanted parts. You can easily do it with a very um, good speed, right? So that's another one thing that I forgot to add it, right? So here you can add this one, that heap is fast and this is slow compared to heap, right? So another thing, when you are executing things, this is important. That's why. So that's another important thing that we just discussed, right? So I hope you got an idea about these things, right? So stack is linear, and because of that, um, there are some problems with that way, right? And these operations, how it is getting managed, the space is important, right? Um, Okay, so I hope you get an idea. And when it comes to another thing is tech is more, um, less in cost, and heap is more costly, right? So when you are going to replace something in a RAM, if it's not working or something like that, this is less cost, right? Because it doesn't have much speed and all. Cost wise, this is less cost, right? Some of the things that we consider when we are maintaining a RAM, that is here, right? Less cost, and this is um very, right, more cost than more costly than uh stack, right? So they will be asking questions based on these ones, right? So the main problem with stack is shortage of memory, right? Because it's not getting removed once it's processed, right? So remember that as well. I thought to that, because these will be questions, right? So disadvantages of stack is those things, right? So, stack is having a shortage of memory because of the things that we discussed, like fragmentation issues, the resizing problems are not, like because of that. There will be, sorry, in here, stack is having shortage of memory, and there will be things about that. And when it comes to fragmentation part, sometimes it's hard to manage. If it's a huge file, if it's fragmented, you are having issues with that, right? So that's why in here, because of this fragmentation, sometimes it is hard to manage this part, right? With because of the fragmentation issues. Right? Sometimes it's good to fragment if it's a huge, like small file, but if it's like big file, it's hard to manage it, right? So that's how we can actually get this one, right? I think I wrote it wrong. Yes, this is fast, this is slow, right? Because when it comes to stack, because it's you know fragmentation doesn't happen, this is faster. But there are some disadvantages as well, right? um Cost wise, anyway, this is more slow, and that way. Please remove, you know, don't get confused. Sometimes, when we are uh, writing on differences, we get somewhat confusion happens, right? So always remember, because stack is not getting fragmented, it is getting fast and uh, like that way, right? But if it's getting fragmented, you have to find the separate pieces where it is stored. So it is getting more time to work with a heap than a stack. Right? So remember it in that way. Because of fragmentation, this is getting slow in heap, right? That's why it's um, a disadvantage in here, right? So that's the part that I wanted to add. So these are some of the like features of heap and RAM, and in stack. It is important. So can see we just did only one slide, right? But see the things that they can ask on here, right? When it comes to RAM, when it comes to hard disk, there will be a lot of questions related to these. So always you have to get a better idea of these execution parts, right? So add these two parts that I added, right? If you don't have space to add these two, which I added new, you can add it to the uh, section that we wrote here, that stack is faster and heap is slow, right? That's also fine. As you want, you can change. You can tell me once you're done with that part, right? And we can discuss on the next parts later. All right then. So we were here, right? So when it comes to you know, the stack heap, you have idea about it, right? So here the execution happens that way, and let's go quickly to the uh locatable programs, right? So this is how a CPU is getting loaded. There's a in CPU there are three things, right? So if you can remember, um, right? So this is how a CPU is. There is one section which is called arithmetic and logic unit, right? ALU. We have right. So next is you have a control unit, right? And please draw this part as well. And the last part, which is here, it is called memory registers, right? So whatever you process in your computer CPU, central processing unit, is getting saved in, the instructions will be saved in the memory registers, right? It's a very important place. So how it is getting stored is inside here, right? So CPU, how it is managed, you should have a idea, right? So ALU means what, as I said, arithmetic and logic unit, right? Arithmetic and logic. Okay. So whatever you are processing, like uh, calculations, anything related to your computer's processing things, right? It is done using here, right? Calculations, process, comparisons, right? And CPU's control unit does the controlling the physical components. All the hardware items will be controlled by the CPU, right? So we are now in the CPU side, which is also an important part when it comes to here, right? If you can get an idea about this part, right? Let me know if you have any questions related to this, right? Usually, it's important, and that's why we discuss about it, right? So control the structure and memory registers. It stores all the data which is being, uh, you know, mm, So whatever you process in a CPU's uh, ALU and control unit will be stored in the memory registers of a computer, right? So memory register stores the data being processed inside CPU. How I remember it, right? You can see when it comes to things, always make it really simple to understand, right? So where this relocation register is, to understand it, you should know what is a memory register, right? So that's how you can make it easy to understand. Inside CPU, you have something called memory registers. So from there, it is getting loaded to the RAM, right? So this mapping happens in this way from CPU end to RAM, right? So whatever you are processing inside, the calculations and the comparisons or whatever you do inside CPU will be stored in a memory with the logical address, right? So easily you can find where it is being stored in your RAM, right? So CPU and RAM is connected, and then RAM is connected to the hard disk to store the uh, most things that you want to store as permanent details, right? So permanent things will be stored in the RAM, uh, from RAM to hard disk, right? But when it comes to CPU, all are these are uh, storage devices, how we connect with the CPU, right? So CPU doesn't store things which are inside our computer. It is getting stored permanently in hard disk, temporary in RAM, right? So when there's a power cut or any power failure, right? Whatever you have in your CPU and RAM will be removed, but whatever you have in hard disk will be stored, right? It will be not erased in your hard disk, right? So whatever we are talking right now are in temporary storage, right? So permanent storage, we have to go next, right? So that's how these storage related things work. So slowly write this down and let me know. So we'll discuss on other parts, right? All right. All right. So when it comes to here, I think you got an idea about this part, right? So we have to get the ALU thing what happens, right? And CU control unit, right? So and this one. Okay. So in memory registers, you have the relocation register. So easily you can find the place, right? So this logical address and physical address. These are some things that are related to how it is stored in registers, right? So not much required actually, but to get a good idea about RAM, I think is more important, right? So this what happens here is you can see there's a relocation register where you have the logical address and physical, right? So these are two things. Like physical address is in a memory. If you are going to store something, it will be physically storing it in a part like here, right? But when it comes to logical address, it is related to logic unit, right? So whatever you are calculating and all, it will be in a part in your memory registers with the logic address, which is 346. So easily you can find the correct memory location of your file, right? And when you are going to convert it and save it in your RAM, it will be having a separate address because it's a physical memory you are going to store. So here it will be converted or saved as 14346, right? So we are adding a uh, 14 in the beginning because you are mentioning that out of 14, you are linking these two, right? That's why it's 14346. So this 000 will be allocated to this, right? When you get a new part, like a new file it is going to save, it will be having 347 and it will be stored in memory as 347, right? So here 14346. That's the address or the identity of this part, right? And next one, it is having, uh, we are going to source 347, it will be 14347, right? So that's how you can get the idea about this logical and physical addressing. Because you are going to store it in your memory, you will be storing it with a ID, like one is 347 and next is 346, like that. So to identify what are getting processed inside your CPU and getting stored in your RAM, right? To understand that, that's the part. That's how these two convert and store. Okay, so nothing much to discuss here then. Here the logical address, how it is getting converted to a physical address. That's the part that we were discussing. Try to just identify how the logical address works and physical address. Uh, right. So and so we'll just add this one part here. When it comes to logic and physics, you should know, the difference between these two. So one small, um, you know, kind of a thing about it is enough. So logical address and physical. difference, we can write it down. Right. So logical address, it is more into how the CPU's memory registers are getting stored, these things that is getting executed at the RAM, sorry, CPU, right? And physical address, we try to see how it is in RAM. That's what we discussed. Same thing, we are going to write it here. So when you asked about these questions, you will get a better idea about it, right? So logical address is generated by CPU. It is a virtual address. Right? And when it comes to physical address, it is a physical location corresponding logical address. Right? So that's how we can get the idea, right? So if I add these things to the note, it will be a huge note more than these pages, right? That's why I want you to write it because it's 77 pages note, right? So don't want to make it more hard for you to remember, but these are important. We can't help it, right? So otherwise, I would have asked you to do different, I can write all these things and make a like 100 pages note, right? There's no use of it, but you need to know the manually how it is being done. So this is to for your to study, right? So when you're studying, these are the most important things, and you can refer to the diagrams that I have added in the note that I shared, right? So you get the physical and logic address difference, and this is actually in RAM, so we can just get these two separated, right? So it is um, generated by CPU, but to store it in the physical uh, place, right? So this we can write it down. And there's one more thing to write. We'll discuss on it. First, write these two down. Right? I hope you can see my last part of the screen. Let me make it bit uh, down so that it's easy to see. Yeah. Right. So there's one called MMU that I have added here, that is Memory Management Unit. Right. Memory registers, you have a thing called MMU, Memory Management Unit. All right. So here the logical address can be viewed by the user, right? But you can't view the physical address anytime, right? Because it's generated by the memory unit, right? MMU. So there you can't view it like that way, right? So you can't view the physical address, right? That's how you have to remember the difference between these three uh, like these points. You can easily identify what is physical addresses, what are logical addresses. Okay. Let me know if you have any questions on how it is in CPU and RAM, because I'm slowly doing it so that you will not get any confusions, right? So it's important how you identify these stuff, and try to write these three and tell me when you are finished. Okay, then we'll go to the next part. Right? So, different types of operating systems, right? So, when it comes to operating systems, there are some things that you have to know, right? So, here, if you can see, uh, Microsoft Windows, Linux, right? Those are personal computers, right? And there are some computers that we use as mainframes, right? Mainframe, super, there are different types of computer types, right? So here, Windows, Linux are for personal use, right? This is based on the processor, right? So based on the CPU, it depends, right? So if it's a Unix, ZOS or OS 390 or VM virtual machines, we have mainframes, right? What are the types you have? Personal, mainframe, supercomputers, right? So personal, there's another name that is, we can say as microcomputers, right? So remember that personal computers can be taken as micro devices, right? So these are the things you have to note, right? Micro devices, this is same thing, right? And when it comes to mainframes, these are all kind of server kind of computers where you can do a lot of things, right? So another type of thing, which is mainframe, right? So these are huge computers. You need a specific room to store these kind of computers, mainframe computers, right? So you can search how these are there in your, as an kind of a homework. Try to find different types of mainframe computers you have, right? So I'm trying to and letting you understand the differences, right? So same way there's an operating system separately for Mac OS, right? So X server, those are another company, right? So Windows is one company which uh, is there to get, these computers are getting created or invented by Windows Corporation. Other one is Mac, right? Those are the most popular brands which are there to get computers, right? So these are two operating systems that we can use for normal use, right? So mobile phones, you have Symbian, Android, iOS, right? So these are all coming under micro devices, right? Mobile devices and laptops, desktops, those are under here, right? So when you're writing this part, just write that laptops, mobile phones comes under micro devices, and mainframe you have these things, Unix, um, like that kind of devices, right? Because I haven't added what kind of devices are there in here, right? Mobile phones, tablets, right? All of them you can have here, right? And if you have any questions, Reema, you can ask me anytime because Amla is not here today. If you have any, please do ask so that if she joins and watches this video, she can also understand these things because I want to get both of you in the same space, right? Because otherwise we can't go forward and do the next parts in the operating system unit, right? Because when we are doing it slowly and steadily, we have to get full marks for operating system unit related questions, right? Specifically in MCQs, you will be asked about the types of computers. So remember, micro devices are personal laptops, tablets, mobile phones we have, and when it comes to these computers, right? Uh, Mainframe, those are server computers, right? Servers are the devices which use these operating systems, like Windows Server, X Server, right? So mainframes are those kind of computers, right? And supercomputers are something that is there in, say, for NASA, if you're considering, right, for specific things, that kind of processing is required to get the, most up-to-date information. There we use computers like supercomputers, right? So another type of computer and another type of operating system is used in supercomputers. But mainframe is something more, uh, you know, uh, slower than super. And so from the name itself, it says super. So that's why it is used in places like NASA for military requirements in different countries like Russia and all. To store data, you use supercomputers, right? So it has high-tech technology so that you can store data and get satellite information or up-to-date or real-time data when it comes to supercomputers. That's why it is used in these places, and it's really expensive that we can't even think about the prices that these computers are, right? So that's how we can categorize these computer types: personal, mainframe, supercomputers, and there's one more thing which is mini computers, right? Mini computers are like a mainframe kind, sorry, uh, kind of a refrigerator kind of ones, right? Mini means not personal, right? So they are, we store things like if you want to get computers, say, uh, with the client server kind of architecture, it is used in mini computers, right? You have clients and you have a server, and you can use the client computer to connect to the server. That kind of computers are considered as mini computers, right? So I wrote it here itself because you have the names of it here. You can identify that these are personal computers. These are the types of computers used in, like the operating systems used in mainframe computers, right? And as you can see, these mobile phones are coming under personal, right? Or micro devices, right? So what are the four types? Micro, mini, mainframe, and super, right? So once you write it down, we can get the examples as these are the operating systems used in here, because it is important because of the OS type and the CPU type, it differs, right? So write it down with the examples. So easy you can identify these. me once you do this part, Rima, right? You have to just write the name of these devices and what are the types. Like in mainframe computers, servers are used, and NASA military related stuff are in supercomputers. It will be easy to identify these things. All right, great. Right. So I didn't wrote any note for that because it's not required as much as other things, right? So just in case you can see based on the users how this is getting mapped, right? So it is single user and multi-user, right? So mainframe and supercomputers are multi-user computers where you can get a lot of users, computer users, to work in a computer in multi-user platform, right? So that is important when it comes to these stuff, right? What are real time and what is these things, right? So different types of OSs based on different player things, right? So these are some of them. We can write it down like this way. Uh, right? One is based on the processor or the CPU. It will be dependent and it will be based on single user and multi-user, right? So other one is based on single task and multitask, right? So that's how we can get these things, right? So processors wise, mainframe, supercomputers, they use uh, those things, right? So you can categorize them as, um, server computers and which are multi-user computers. Right? So you're going to write it like this way. Multi-user, it is mainframe supercomputer. Single user are these ones, personal computers, which use um, Windows and Mac OS. Right? So processors, mainframe, and this one it is personal computers as micro devices. Right? So that's the categorization that you can do based on this. And the other one is like single task and multitasking, right? So single user, multi-user, right? So that's the difference. I hope you got the idea, right? So in Unix, it is a way that we do it. One user can use it at a time. Right? So write it like this way so that it's easy to understand what is single user and multi-user. Several users can use the computer at the same time. Okay? And these computers, they use Unix and X server. These are the examples like this. If you can write them, what are mainframe, super, and what are these? It is important to understand these two. Okay? And next one is single task and multitask related area. There's another one that we use, disk operating system, right? DOS is. Write the full form of these ones, right? If it's disk operating system means DOS, right? So before we got Windows, there was a operating system that is being used, which is DOS, right? MS-DOS. So there will be questions based on these parts. That's why this part is important when it comes to what's the difference between single user, multi-user. There will be questions. What is the difference between single task and multitask? There will be questions, right? So it's important to understand that part. So that way we can understand it in a better uh, idea about it. Let me know once you finish that part. Yeah. So class will be finished now, Rima. Right? We'll finish it after this part. That's the last part of our class today, right? So we did up to um I think 13th no slide in the operating system part, right? So like that we'll try to complete the rest of the parts in our class, right? So I think it is easy, not the hard part. Yeah, tell me once you finish so we can complete on this part. We can wrap up once you complete it, right? Uh, all right, then we'll meet on next Sunday, same time for the next class, right? If we can, we'll meet on Thursday. I'm not sure if Amla is available, right? Or else we'll meet on next Sunday, right? See you then. Have a good day. Bye.